let's say that f of x is equal to the absolute value of x minus 3 over x minus 3. And what I'm curious about is the limit of f of x, the limit of f of x as x approaches 3. And just from an inspection, you can see that the function is not defined when x is equal to 3. You get 0 over 0. It's not defined. So to answer this question, let's try to rewrite the same exact function definition slightly differently. So let's say f of x is going to be equal to, and I'm going to think of two cases. I'm going to think of the case when x is greater than 3 and when x is less than 3. So when x is, let me do this in two different colors actually. When x, do it in green, it's not green. When x is greater than 3, what does this function simplify to? Well, whatever I get up here, I'm going to get a positive value up here, and then when I take the absolute value, it's going to be the exact same thing. So for x is greater than 3, this is going to be the exact same thing as x minus 3 over x minus 3. Because if x is greater than 3, the numerator is going to be positive. You take the absolute value of that, you're not going to change its value. So you get this right over here. Or if we were to rewrite it, this is equal to, for x is greater than 3, you're going to have f of x is equal to 1, for x is greater than 3. Similarly, let's think about what happens when x is less than 3. When x is less than 3, well, x minus 3 is going to be a negative number. When you take the absolute value of that, you're essentially negating it. So it's going to be the negative of x minus 3 over x minus 3. Or if you were to simplify these two things, for any value, as long as x does not equal 3, this part right over here simplifies to 1, so you're left with a negative 1. Negative 1 for x is less than 3. And I encourage you, if you don't believe what I just said, try it out with some numbers. Try out some numbers, 3.1, 3.001, 3.5, 4, 7, any number greater than 3, you're going to get 1. You're going to get the same thing divided by the same thing. And try values for x less than 3. You're going to get negative 1 no matter what you try. So let's visualize this function now. So now let me draw some axes. That's my x-axis. And then this is my f of x axis. Y is equal to f of x. And what we care about is x is equal to 3. So x is equal to 1, 2, 3, 4, 5. We could keep going. And let's say this is positive 1, 2. So that's y is equal to 1. This is y is equal to negative 1 and negative 2, and we can keep going. So this way that we've rewritten the function is the exact same function as this. We've just written in a different way. And so what we're saying is our function is undefined at 3. But if our x's are greater than 3, our function is equal to 1. So if our x is greater than 3, our function is equal to 1. So it looks like that, and it's undefined at 3. And if x is less than 3, our function is equal to negative 1. So it looks like, let me do it in that same color. It looks like this. It looks like this. Once again, it's undefined at 3. So it looks like that. So now let's try to answer our question. What is the limit as x approaches 3? Well, let's think about the limit as x approaches 3 from the negative direction, from values less than 3. So let's think about first the limit as x approaches 3, the limit of f of x as x approaches 3 from the negative direction. And all this notation here, I wrote this negative as a superscript right after the 3 says, let's think about the limit as we're approaching. Let me make this clear. Let's think about the limit as we're approaching from the left. So in this case, if we get closer, if we start with values lower than 3, as we get closer and closer and closer, so say we start at 0, the f of x is equal to negative 1. We go to 1, f of x is equal to negative 1. We go to 2, f of x is equal to negative 1. If you go to 2.999999, f of x is equal to negative 1. So it looks like it is approaching negative 1 if you approach from the left-hand side. Now let's think about the limit of f of x, as x approaches 3 from the positive direction, from values greater than 3. So here we see when x is equal to 5, f of x is equal to 1. When x is equal to 4, f of x is equal to 1. When x is equal to 3.000001, f of x is equal to 1. So it seems to be approaching positive 1. So now we have something strange. We seem to be approaching a different value when we approach from the left than when we approach from the right. And if we're approaching two different values, then the limit does not exist. So this limit right over here does not exist. Or another way of saying it, the limit of, let me write this in a new color. I have a little idea here. The limit of a function f of x as x approaches some value c is equal to L if and only if the limit of f of x as x approaches c from the negative direction is equal to the limit of f of x as x approaches c from the positive direction, which is equal to L. This did not happen here. The limit when we approached from the left was -1. The limit when we approached from the right was +1. So we did not get the same limits when we approached from either side. So the limit does not exist in this case.